And great to see you all. We could be outside enjoying the climate, or at least the weather. You might well say, well, if this is climate change, I'll take it. But of course, this is weather change. And just think if we'd had bright sunny days like this for the last 4 months or 2 months even, it would become a worry because we've had several feet of rain, I expect. It certainly seemed that way. And that fills our reservoirs and drives our turbines and gives us water to drink and gives us water to irrigate with, and so on and so on. So weather and climate change are different things, of course, mostly in their time perspective. So you're aware that it's Britt Ray's book that's kind of brought us all together on this issue. She's a bright gal and a great writer. And in the book, of course, she focuses on the psychological reactions to climate change, particularly among the younger population. So she more or less takes the science of it for granted or as a given, and then the consequence of climate change she takes as largely apocalyptic, right? They have psychological consequences. This presentation is going to argue that science is a necessary but insufficient consideration in answering the climate change phenomena. We'll consider in turn the whole phenomenology of climate change is not just a bunch of weather, it's a whole bunch of stuff associated with that. Secondly, what science plus engineering and technology could do about climate change. Thirdly, the necessary place of theology and humanities in considerations of climate change, because there is a values piece to this, clearly. And then harnessing the modern power dynamic of business and politics in response to climate change, because it's a human problem and human beings have to solve it or deal with it. And then the final section will draw a number of conclusions. So let's start with the phenomenology of climate change. It's more than just what you see outside. It's a whole bunch of stuff. Climate change is a natural phenomenon with quite dramatic shifts over millennia of time. But human-induced climate change on a global scale is a phenomenon defined as taking place starting with the Industrial Revolution some 200 years ago. The essential process, as you know, of course, is the increasing amount of carbon dioxide that's in the atmosphere. And it's important to notice, I think, that without some carbon dioxide in the atmosphere, the Earth would be much colder than it is. There's always been some, and we've just been adding to it, and it's what we've been adding that is mostly the problem. Global warming is therefore a result of human-produced waste products. Actually, carbon dioxide is a waste product from combustion in engines and various other things. So the long history of humans and their waste is a helpful context for understanding our present situation. So I'll just go through this quickly. Solid waste has an interesting history. Ancient societies, had their waste to deal with as well. And generally speaking, they just let solid waste build up in their cities and in their alleyways and so on, and then kept building the city higher and higher and higher. And it seemed to work okay. And as a matter of fact, we're in the southeast of Vancouver, we have done exactly the same thing. Like Champlain Heights is built on the old garbage dump. And in Delta now, you've got quite a mountain appearing there on the north side of Delta. And I presume they're going to turn that into a housing development. Who knows? But solid waste, has been around forever, of course. And it seems to be more or less manageable. The things that are not manageable are the things that are not organic, in other words, like plastics and stuff like that. But that's our very recent invention, of course. In the case of Jerusalem, for example, the ancient city of Jerusalem, it was very convenient that Jerusalem was on such a high mount. They could just shove stuff over the edge, it would fall down, and keep some fires burning down there, and that would be a way of dealing with solid waste, not the ideal perhaps. But you know, there's fires burning in our dumps too. Um, as far as human waste is concerned, there was actually a dung gate. There's 12 gates in Jerusalem. One of them is called a dung gate. You could try some other words for that if you like. There you go. Solid waste is a deal, an issue from the beginning. Then there's liquid waste too, of course, and this seems to have not been too much of a big issue in ancient times because it would just run away by itself. Where it goes, who knows? Maybe it does wind up in a river or creek or something, but it goes away by itself. And in ancient cities like Rome, they did have public latrines with constantly running water that would flush things out, and we knew that that would go into rivers and so on. In London, in the hot summer of 1858, the Thames River was called the Great Stink because it was literally the sewer of the entire city, and it leaked into Parliament, and then it got some attention from the politicians. So in 1962, and I remember reading this book about that time, actually, that tells you something. Rachel Carson's Silent Spring book got a whole lot of attention. It was about liquid waste, essentially. But not just any liquid waste, but non-organic waste. If it's just runoff from fields where animals and so on are producing their waste, that's organic, and it sort of looks after itself. It returns back to the soil, so to speak. But in the 1960s, we were just getting into the plastic age in a big way, and so we had synthetic chemical fertilizers, we had pesticides, and so on. And she really highlighted this in a very powerful way. So whereas in previous times, perhaps liquid waste running away by itself was not so bad because most of it was of an organic nature. But now you've got all these synthetic things running into lakes and rivers and streams, and they don't go away. They don't deteriorate, they stay and create problems for aquatic life and so on. So there's the liquid waste side of things. Then there's also the gaseous waste, right? We have solids, liquids, and gases, right? So more recently, say into the 1970s or so, we came to realize that we're also poisoning ourselves with various noxious gases from automobiles, for example. I remember driving on Oak Street in Vancouver, sitting there on a hot August day with the light not turning green, and it was choking. You could see it and you could smell it, and it was not pleasant. So thankfully, we got onto it fairly quickly and fairly effectively, and created catalytic converters. These became required. Now there's no car made without them, and everything has improved a lot in that realm. Similarly, with the gases used in refrigeration, they used to contribute to the big hole in the ozone layer. That's been largely fixed, and Sam tells me the ozone layer, the hole is shrinking. So we've had some successes in dealing with this, which is very encouraging. So what's the current state of world climate then? First, climate change is a long-term process, of course. Weather change may be measured in hours or days, but climate change has been used to describe changes over centuries or even millennia and longer. Such changes are usually estimated from ice cores, which is something that Sam does. But by general consensus, when we're talking about climate change now, we put roughly a 30-year period on it. If it's the weather over 30 years or more, is more or less the way it's defined. Another difference is that now when we talk about climate change, it's primarily about the atmosphere, somewhat about the oceans, and not much about the land, although all three, solids, liquids, and gases, are involved. The land masses of the Earth are generally fairly stable. The oceans less so, and of course the atmosphere very much less so. So the importance of the atmosphere of the Earth to the well-being of human beings and to all other living things can hardly be overestimated. It's the air we breathe, of course it is. Several times every minute. Without it, we wouldn't be here. It's the ocean we swim in, of course, and a whole lot of other creatures swim in it as well. And it's the unavoidable and completely necessary context for the function of all life. So it needs to be thought about. So what are some of the responses to the climate change narrative? I'm calling it a narrative. It's not just the one thing, but there's stories told about it, reactions to it, and so on. So the overall climate change narrative has many elements, full of contradictions, actually, ironies, and self-promotion even. First, there's the anxiety produced by the threat of it and by it itself. It's just like the nuclear threat of the mid-century, I would say. I remember quite a bit of that. As a matter of fact, large numbers of people were totally freaked out with the possibility of nuclear annihilation. And some new neuroses were defined and looked at, and people were really, it was a very stressful time. One difference there is you only had about 2 big players in the world to worry about, and whereas now, of course, you've got everybody's a player in this war, in this challenge. So there's the threat of it all. Secondly, there's the political and media fixation on climate change. It's an absolutely ubiquitous topic. You can't get away from it. It's all out there. And tons of books, journals, countless articles, blogs, media threads. Climate change sells, actually, and this is not being missed by publishers. Also not being missed is the opportunity for public personae like politicians, the uber-rich, high-profile entertainments to grandstand and lecture others and pose as saviors, while all the time adding their own exaggerated carbon footprint to the mix. There's a tremendous amount of business activity that's being created by climate change narratives, such as heat pumps for homes, efficient appliances, smokestack scrubbers for industry, waterway remediation, electric cars, new kinds of batteries, wind farms, solar farms, and much more. The profit motive in this whole mix is really quite big. I've particularly noticed the fact that some of the technological and business solutions to climate change have their own additional climate impacts, like wind farms that kill birds, or constructing wind towers off the east coast of the U.S. was killing whales there about a year ago because the pounding of the pile drivers was interfering with the whales' navigation system or something like this, and killed a bunch of whales. And of course, tourists going to see the last remaining polar bears, you know, they're going to spend quite a bit of money and carbon flying there and driving there and getting there and so on. And some of these exotic cruises to the Antarctic, I'm going to take one soon, I hope. You got to you burn some carbon to get there and see these ice sheets melting, so it's an issue. One might say that the ultimate irony about human-induced climate change is that the Industrial Revolution was an enormous boon to humanity, increasing its material well-being manyfold and its life expectancy dramatically. And if this were not enough, all of this happened and continues to happen while the world population grows from a mere 1 billion, in 1800 to 8 billion now. So all of this improvement in the material well-being of human beings has come at some cost. and it seems that perhaps now it's time to pay. So, what's the place of science in all this? Excuse me, I just need a bit of water. At least some of the problem of climate change is scientific in nature. That is to say, it's about the physical world. We do need science to tell us, like only science can, if there really is a problem. And if there is, what is it exactly? And how bad is it? And what can we do about it? And what time frame have we got to fix it? And how will we know if we have succeeded? Other questions that are not mainly scientific are, is the ideal Earth a planet whose climate does not change? Is that what we're driving for? Can we really define what the planet's natural state is, or could be, or should be? And then there are very practical questions of engineering, technology, funding, and politics that are, strictly speaking, beyond the remit of science. So science has a very critical place to play, but of course it's insufficient to look after the whole ball of wax. So I want to take you through just a bit on science. Sam is the scientist. I'm not, but I have a very serious interest, and so I'd like to go through this. What science deals with explicitly, of course, is the solids, liquids, and gases of the world we live in. And in relation to climate change, this means it deals with land, oceans, and the atmosphere. And the interactivity of all of these elements is sometimes illustrated by the so-called butterfly effect, which says that the movement of a butterfly's wings on the other side of the planet can affect something much more drastically on this side than you might imagine, because there are multiplying effects. In creating any comprehensive model of climate change, there are serious issues about starting conditions. You can have your model, but you have to start it with something. So those starting conditions are very critical. And there's unknown exponentials, there's tipping points, there's possible discontinuities, all of these to be considered. The scientific method is really what gives it its authority and strength, and it's helpful to understand this as well as we can. So what the scientific method does is essentially make observations about a problem or phenomenon in the natural world, then creates a hypothesis about what might cause this phenomenon or account for it. This hypothesis then has to be tested against real-world data so that a theory can be formed, and then the predictive capacity of this theory has to be tested as well against actual real data. So most of this methodology is practiced in other fields too. In the humanities, we do similar things and so on. But the distinctive things about science, I would say, are its experimental method and its subject matter. So by experimental method, we mean that science can does actually feel free to manipulate factors, yes? Now some factors can't be manipulated, but if you think of yourself sitting in a lab, and you can say, well, what happens if I add 10 milliliters to this solution rather than 20 milliliters like I did yesterday? What happens then? Let's try this, what happens then? So science is able to do that, is well within what's accepted, and so that's one thing that's unique about science. And the other thing is that subject matter, like it's explicitly about the physical universe. People do talk about other things as well, of course, science conferences and other things, but strictly speaking, science is about the physical universe. So how are we doing time-wise? Are we good?
You were at 18 minutes, so.
Okay, fine. Okay.
10 more minutes or so.
Okay, so we'll move it a little faster. Yeah, so let me just focus on this for a bit. A scientific approach to climate change would need rigorous and quantified definitions of measurable variables. One would expect that there might be any number of independent or input variables. There could be tons of things that go into changing climate, and one might hope that climate change itself could be limited to a few outcome variables. Well, in the last 30 or more years, science has been able to reduce this all down to something that sounds pretty convincing. It's in fact, science has reduced climate change to a few things, and this is going to be good enough until we find a better construct. So we have the rise of average global temperatures since the beginning of the Industrial Revolution as the outcome variable. Now that's really reducing a lot of things to one thing, and there's risk to that. And we won't really know the results of this grand experiment for quite some time yet. And by then it could be too late, who knows? We just hope and pray that science has got this right. And there's reasons to think they have. And we have the increase of so-called greenhouse gases in the atmosphere as the input variable. Being able to reduce the input to one variable, it's quite fascinating, interesting too. It makes quite a lot of sense. It seems to be credible, but again, we won't really know until the experiment is over, which is quite some time from now. Temperature is the main driver of air movement over land and the oceans. The temperature of air itself depends partially on the composition of that air, and so on. So some gases comprising the air we live in, like carbon dioxide, will trap the sun's heat, will not release it back into space in what's called the greenhouse effect, as you know. Okay, just going to skip the next two sections, Michael. Yeah, so science is very, very useful in defining problems and measuring them, especially in the physical world. But for us to do anything about climate change, science itself doesn't really have a mandate to do that or the authority to change anything for you and for me. It takes technology and engineering to create working solutions. It takes business to make economic solutions, and it takes social science, regulatory regimes, educational and religious and other institutions, and politics to bring about large-scale changes in human behavior. And this is really the whole issue, isn't it? That science has helped us to define the problem and what steps could be taken. But it all amounts to having to change human behavior on a large scale. And that's no small thing, as we can all very much appreciate. So this leads me to a section about the necessary place for theology and the humanities, yes? The humanities, for example. Any action taken by human beings reflects something of a worldview and a value system. This is unavoidable because we have to choose between this and that. And this means that our value system is engaged and is unavoidable. So the general goal of climate science, as we've said, is to limit the global temperature to not more than 1.5 degrees centigrade above pre-industrial levels. This is a values call, among other things. We assume that if we can do that, we'll have a better life, we'll have a more favorable planet, and so on. Nobody's ever done this before, and so we're hoping that we've got it right, and there are reasons to think we have or just about have. But we could ask, were pre-industrial temperatures ideal? Like before the Industrial Revolution, was everybody totally satisfied and happy and everything was working for everybody and so on? Well, maybe not. Will it be ideal if we can limit it? Will it be ideal for everybody? Will it be ideal for a long time? What makes this ideal? These are all value considerations. To me, the notion that in the Western world, with its very long history of progressivism, would choose a state 150 years in the past as being ideal is, it's quite remarkable, and perhaps entirely unprecedented in the history of Western civilization. I don't know. To me, it raises the question: have we lost in this post-Christian era? Have we lost our capacity to look forward and imagine better things to come, rather than having to go back 150 years? Now, I don't want to overplay that, but it's a significant consideration, I would think, about the culture that we have come to live in. So, all of this raises the important question: what is humanity's vision for a quote-unquote ideal planet? Volcanoes are highly disruptive to human societies, but would a planet without volcanoes be more ideal? I don't know. And lightning causes forest fires and wreaks all kinds of other havoc, but would we eliminate lightning if we could? I don't know. I think lightning is nice. Rock slides, caving off beaches, flooding of low-lying areas, and silting of harbors is deeply troubling to mankind. But it's the straightforward result of gravity, so we're not going to change that anytime soon. So even if we could go some distance to creating a more suitable environment for humans, there's still what about the rights of animals and the rights of forests and so on and so on. We're not the only creatures or living things on the planet either. So the values question is what makes us human, of course, and the values question is far from being a trivial matter, that's for sure. So a place for the humanities, and humanities in Canada and elsewhere are so grossly underfunded and undervalued. It's awful. You wonder what kind of a world we really have got going here. What about the place of Christian theology? The worldview question is profoundly human and a theological question. We must add that a worldview does not take full account of human nature and utterly human drive to individual, autonomous, personal power is not realistic either. So in the end, human beings are responsible for climate change, but the Industrial Revolution, which gave rise to this increasing carbon dioxide, the Industrial Revolution has been such a boon to human beings, especially in the West, and its gains and ways of life will be impossible to give up. So it's going to take quite a worldview challenge to change into this. It'll be remarkable if a solution to climate change will be made effective without disadvantaging somebody, because it's so helpful to those who have the power that has been given in the Western world. The very long-standing Judeo-Christian heritage of the West had a deep understanding about why the earth and nature have not been continuously pristine, right? Why isn't the earth beautiful all the time? And why human beings cannot arrive at completely satisfactory and long-lasting answers to the human condition. The West having been now largely abandoned the West having largely abandoned any consciousness of its Judeo-Christian roots is largely lost in the face of serious challenges to the very continuance of the human race, as Ray points out. Searches are on for other ways of seeing things. Indigenous cultures are one such offering, especially in the New World of North America and Australia, for example. This is found to be attractive by others, by many, and there are other kinds of wisdom around as well. I can skip some more of this. Yes. How are we time-wise now?
5 minutes.
Okay, great. Okay. So, because this is a human problem, not just a physical world problem, um, but in order to affect change, we have to find ways to organize the global power structures to change climate, yes? First you have to define the problem and the most advantageous solution with a measurable target, and that's been done. Science has done a great job on that. 1.5 degrees, or maybe it's 2 degrees by now. It's tough, but it's been quite well defined and what possible solutions are. Choosing the most effective and efficient means of achieving it. This is, to reduce the carbon footprint, et cetera, et cetera. And these are big undertakings. The comparable thing was perhaps the nuclear threat from 50 years ago. A comparable thing might also be the COVID issue, which is a big worldwide thing, had to be handled in the best way we could. Certainly you have to rally political support and commit financial resources to all this in order to make it happen. And this is difficult to do because you're having to negotiate with all kinds of people and countries with all of their own ideas and purposes, all of the blame game going on. The West has benefited most from the Industrial Revolution, so therefore they should pay more, and so on and so on. It's an enormous negotiating problem. And then we have to establish a regulatory environment for public and private players, because we all play in this space. Nobody is exempted. Every company, every corporation, and every individual, every family is involved in this thing. So how to establish regulations that are fair and meaningful and implementable, it's a humongous job. The only people that have ever tried something like this on a global scale would be something like the United Nations, I guess. And they weren't really set up for this problem, they were set up for another problem. So how well they will really do, I don't know. Some of what I see is not too encouraging. And then we have to implement the processes, measure the results, and adjust accordingly. So I think it's important still to think of our climate mitigation thing as one grand experiment. We hope it works, and we have every reason to think that it might, but we've never done this before, not on such a grand scale, not with this particular issue, so it remains to be seen. There's obviously much persuasion needed to create fairness and assigning responsibilities and so on. Okay, I'll just go through some concluding remarks here. So the answer to the opening question, yes, science is a hope-filled perspective on climate change. Yes, absolutely. Without science working on it, we would be much less well off. The fact that they can reduce very complex things to single numbers is pretty astounding. We hope they're right. Of course, we're all working towards that magic number, so to speak. We'll see. It's a grand experiment. We have to get involved in it, and so on and so on. Secondly, everyone on the planet is now better off, at least in material well-being, than we were 200 years ago, as the result of the Industrial Revolution. And on top of that, there are 8 times as many people on the planet now as then. So this is a totally remarkable achievement. And the planet has suffered through this, let's say. This planet is remarkably resilient, considering what 8 billion people have been doing to it for 200 years. So maybe it's time to sit up and pay attention, though, to see if it really is that resilient. And that's what we're all talking about, of course. Human beings need to be very aware of what's happening. I think modern science is best placed to give us the information, the facts, and how fast, and so on and so on. But before implementing any solution, of course, the value choices have to be made, and it's not always obvious. It's not clear that everybody agrees what these value choices need to be. So this has religious, theological dimensions which really have to be thought about, and it's kind of unfortunate, I think, that humanities, theology, and so on doesn't have the kind of funding that can keep it up to speed and up to date with all of this stuff. It doesn't have that value in our world. And so it'll take a lot of skilled negotiating capacity to get anywhere on this file, and we are getting somewhere on the file. So far, fairly encouraging, I would say. In the meantime, while we're waiting for things to get better, we have to find ways to survive, and this is what Ray's book is all about, of course. And I think the Christian worldview is particularly helpful in all of this because it has a teleology, like it believes that the earth has a purpose and it's going somewhere to a definable end, and so human responsibility and relationship to it is defined in those terms, at least up to some point. And Christianity's great trinity of theological virtues, faith, hope, and charity, speak well to what Ray has been concerned about. There are some ongoing questions still, though. What will be the result of this grand experiment in reducing climate change? We hope it works. But you could still ask, have we really defined the problem correctly? Is average world temperature the best measure for it? And has it been measured accurately and consistently for the 200 years and even before that, and so on and so on? If we manage to contain this temperature, what will we see? If the temperature could somehow be brought back to pre-industrial levels, would we see less hurricanes, less forest fires, less flooding, less hot summers? It's an interesting question. I don't know if the answers to that are altogether clear. One thing I wanted to note in closing then is that there's one factor which I don't think has had much play, and that is the human population, at least on some studies, the human population of the planet is on a trajectory to slow its increase, not just slow its amount, but slow its increase, and then begin to decline over the following number of decades near the end of the 21st century. This seems to be fairly credible. And so if this is a good prediction, that the overall human load on the planet will decrease, and we see some signs of that already. This may be a help in reducing the load on the climate on the planet. And interestingly, Britt Ray's concern about having a baby, plays right into that there must be lots of people who are thinking that way, or who are legislated, to limit it, and so on and so on. Okay, that's what I've got to say.
Sam, the floor is yours.
Okay. Well, thank you for the invitation, and thank you, Howard, for your talk and laying out some groundwork for us today, raising some interesting points to get us started. I want to now try out some hope-filled thoughts myself from my perspective as a Christian working in climate science, to add to the discussion here. So yeah, from the introduction, as you know, I teach mathematics here at Trinity, mostly calculus and all that good stuff. I did my doctoral work in oceanography, where I modelled sea surface temperatures, and my postdoctoral work was in glaciology, developing computational models of glacier flow to try and help us understand how glaciers might respond to climate change. And here at Trinity, I can continue to do research and publish in both those fields. So essentially, climate models incorporate all the processes of physics and chemistry that are relevant to the climate system. And we code it into a machine and run simulations. Basically, we're creating a digital twin of the planet, if you like. And climate science is a very well established field of science now. We have a very comprehensive understanding of the climate system and how it evolves and what it looks like, what it would look like in the future, depending on emission scenarios. We know that human-caused emissions of carbon dioxide from the burning of fossil fuels results in an increase in the greenhouse effect, warming the atmosphere. It's actually not just CO2, carbon dioxide. There are actually other greenhouse gases that also contribute to global warming. Hence, you might hear or see the term CO2 equivalent. There are also land use changes which can contribute to climate change. So, for example, deforesting the Amazon for agricultural purposes. And of course, the warming of the atmosphere leads to the warming of the oceans. The oceans warm, they expand, causing sea level rise. The ocean absorbs carbon, becoming more acidic. The warming atmosphere and oceans melt the glaciers and ice sheets, which again contributes to sea level rise. So there's obviously many facets to climate change, not just atmospheric warming. The projections of future climate, by all accounts, are quite alarming. This is a serious problem that society must address. We cannot keep doing what we are doing without ongoing significant detrimental consequences. As you can imagine, working as a scientist in this field can be quite bleak. For example, I study glaciers, but they're disappearing. We are expected to lose about half the world's glaciers by 2100 compared to 2015. When I think about that and let that sink in, it makes me sad. I feel a loss for future generations. Glaciers, of course, are a wonderful part of God's creation. They have created some of the most spectacular landscapes on Earth. And we live in Canada, of course, blessed, country blessed with a rich number of glaciers. For example, in fact, the most visited glacier in the world, Alabaster Glacier, on the icefield pathway between Banff and Jasper. Maybe you visited that one yourself. But that glacier is retreating. The ice cap there is dwindling every year. It is and will continue to be a remnant of its former glory, and so I think that's a great tragedy and a huge cultural loss. And of course, then there's the issue of melting glaciers causing sea level rise, and about 200 million people who live within the high tide mark by the end of the century. There are 1.9 million people who live downstream of mountainous areas that rely on glacier runoff. So these are going to cause huge justice issues. And so I can see how you can get caught up in a doom and gloom cycle. I totally understand it. And especially for young people in particular. You know, I won't be around in 2100, but they might, and their children will. It is more real and immediate for them. So where is my hope? Well, as a community of nations, we are beginning to change course. The worst case scenarios, you know, the Mad Max scenario where the whole world becomes like North America, burn as much as we can, as fast as we can, seems to be off the table. The current commitments from jurisdictions around the world will limit warming from pre-industrial levels to around 2.7 degrees. Now, of course, there's still questions. Will those committed policies actually be enacted? Can we do better? I would hope we can do better than that. When we talk about climate solutions, we generally categorize them mitigation. How do we reduce emissions to limit warming? Adaptation. How can civilization adapt to current and future warming? And geoengineering. Think space mirrors or injecting sulfur in the atmosphere, in the stratosphere continuously, forever. And actually, if I just to push back a little bit, Howard, I would say you mentioned the kind of the grand experiment, calling mitigation as the grand experiment. I would see more that the experiment has been the last 200 years of burning the our fossil sources, burning the fossils, and we need to stop that experiment or bring that back to an end. And I mean, in my mind, the geoengineering solutions would be trying to start another experiment, and I think that would be unwise. But basically, we already have the tools and technology to stave off the worst of climate change now. The most effective solutions to halt warming are to transition to renewable energy, wind and solar in particular. And well, it's better for our health anyway. Cleaner air to breathe. And trees. Let's reduce the conversion of forests and reforest. Who doesn't like trees everywhere? Think of Endor, the moon, where the Ewoks live in Star Wars, perhaps. So I do see a transition happening in society. For example, we can all witness the move to electric vehicles that is happening. And that's not necessarily because of climate change, it's probably because, you know, Tesla is a cool vehicle. And who doesn't want to save money on gas? Newer technology is just better. So I see these changes happening already. Now, unfortunately, realistically, I do think 1.5 degrees warming is probably off the table. It will require so-called negative emissions. But let's not give up. Let's try to be as aggressive as we can to lower emissions now and ultimately move towards net zero, to limit warming as much as possible. And I know this creates challenging policy questions. You only have to look at discussions here in Canada around the carbon tax. So we have to be pragmatic. But the sooner we act, the better. Because delays just mean that we will have to be more aggressive later on, and society can only change so fast. The science tells us future pathways. We get to choose. That's immensely empowering. We can, for example, as a global society, a global community, decide, based on the policies we enact, how many glaciers we will bequeath to future generations, how many low-lying island states will survive, whether coral reefs will be around. It is a great responsibility for this generation. But also, if I may say, perhaps an exciting prospect. We can be the generation that brings about this transformation. This is a remarkable position in history we found ourselves in. I think Howard beginning to highlight that you know, what a time to be alive. We have the privilege of advancing climate solutions that can bring reconciliation to the world we live in. This is a result of our capacity for foresight. We have this unique ability as humans to kind of like time travel in our mind. You know, perhaps we're doing it now. You know, when's the next coffee break, or what will I be doing this afternoon? And we've essentially combined that with the scientific method to very clearly and quantitatively lay out future pathways. I like this quote from Philip Hefner, a theologian. He says, "Human beings are God's created co-creators whose purpose is to be the agency, acting in freedom, to birth the future that is most wholesome for the nature that has birthed us." So I like to think of these climate simulations as being indispensable tools for us to live out our calling as co-creators, because they enable us to enact a future that we desire for humanity and for the whole community of creation. These climate simulations are like storylines. They give us plausible future pathways. They can be event-orientated and link the physical and the human aspects of climate change. And they can enable decision-making that can then work backwards. My Christian faith also gives me well-grounded hope. You know, everywhere in the New Testament, we see the Christian hope is directed towards what is not yet visible. A hoping against hope, if you like. It is never too late to act and to do the right thing. I think of Psalm 1. Let's not be at the seat of the scoffer. Let's move from the sedentary to the standing to the walking, as the words of the psalmist encourages. As Christians, we should care deeply about this planet because God does. God is deeply invested in it. And if you like, the whole Bible can be seen as a story of God wanting to dwell with us. So let's build a home worthy of God and his image bearers. You know, God created this special place. He was present in the Garden of Eden. He was present in the tabernacle. He traveled with the Israelites out of Egypt. He was present in the Holy of Holies in the temple. And he came among us in human form, dwelt with us on this earth, on this planet. And even the future, we look at the eschatological vision of the New Jerusalem coming down from heaven, not to replace earth, but to transform it. Once and for all, the whole earth will become the Holy of Holies. Finally, the home of God. The world without end. What a vision. Notice as you read that text in Revelation, it's a world where the natural and built environment are in harmony. So this is a place that God is deeply invested in and has a long-running and ongoing commitment to. So let's use science, enact policies, and live lives that will allow all God's future image bearers to flourish together, together with the whole community of creation. There we go. Thank you.
Questions, comments? Thank you, Howard and Sam. That was wonderful.
It's very hopeful. Thank you. I'd ask what you do personally, given your knowledge in science and how you live this out on a day-to-day basis, because it's very easy to not take personal responsibility, but to project it onto politicians and the more macro level of, you know, corporations and other people need to change. But what you do, given the knowledge that you have as scientists and what you see happening in this earth.
Yeah, I mean, I think it is difficult, isn't it? Because the problem is complex and individual actions, like it needs systematic change. You know, often people say, oh, well, I recycle, which is great. I recycle as well. But one individual recycling is not going to create systematic change that we need, the societal transformation that we need. So I think I do tend to think more on things do need to happen at the big political level, whether that's municipal, provincial, federal, and then through the United Nations, where governments, you know, if Canada just acts alone, it's no good. Everyone has to make steps. So yeah, I mean, I think certainly, you know, when I get a chance to vote in elections, that issues, environmental issues, are certainly at the forefront of my mind. So that would be one way where I think advocacy really matters. Yeah. And I think my work as a scientist as well, I think I have an opportunity to share some of the findings and start conversations with people that are less scientifically literate, maybe. Yeah.
Yeah, that was one question I had is being aware of the challenges that have been created and that we're facing, and wanting to see change both at, you know, the micro, meso, and macro levels. What you're touching on just at the end there is how do we communicate the urgency and the seriousness, communicate the hope as well in terms that are intelligible and compelling, and to the audiences that we were wanting to reach. Because you talked about like the theme of justice that fits into all of this, right? And at times the people who are in positions of leadership, I find that the terms that they use are you know, when they start talking about eco-justice, right, and so on, they're alienating the types of people that they're trying to convince, right? Like the complexity of the terms. Like, I'm not saying, so what is, from a scientific perspective, like what's the best way to communicate, or can we be more strategic in the words that we use, the concepts we use, and how we explain them, so that they're not alienating to people, or it's not going over their heads, but people don't feel like also you're speaking condescendingly? Like, how do we find that sweet spot in terms of communication? I know that's a big question, but it is something that I'm thinking about constantly. Is some of the things that we're dealing with, they don't fit into sound bites very easily, right?
Yeah,
so it's the contrasting sound bite of like, oh, look around, it's sunny, or the planet's getting hotter. Well, it's been the coldest winter I've seen around. So, like, you know, like that's what you're dealing with. It's that's really hard to respond meaningfully to, you know, from the micro to the macro levels.
Yeah. No, I think that's a fair point, and I think as scientists we're trying to learn, we're trying to be better communicators as well, and
theologians too.
We're trying to learn. We're trying to learn that. Yeah. I mean, one way. I think there's a move away from the, you know, just talking about the, you know, 2 degrees warming or 3 degrees warming, but to, you know, what would a 2-degree world look like? What would a 3-degree world look like? What actual things does that mean? And, you know, so we have, for example, I mentioned in glaciers, we know if we're in a 2-degree world, this is how many glaciers will survive. A 3 degrees world, this is how many glaciers will survive. So perhaps that helps to make it a bit more concrete. And then from there, we can kind of work backwards in terms of decision making. I think that's one approach that is helpful, perhaps.
You talked about big experiments, and you both the presentations talked about big experiments. How would you describe the learnings that might be applicable to global warming in terms of the experiment that we were forcibly drawn into with COVID-19? Howard and I, we talked a little bit about some of the satellite imagery of what happened to some of the big cities, both Western cities and Eastern cities. Countries with democracies, countries with totalitarian governments that have an ism that's not capitalism, and yet are big players in terms of consumption when COVID-19 hit. And the satellite imagery shows, it's pumping stuff into the atmosphere. And then I think it was NO2 or something like that. And then what happened after, when they enacted requirements for things to shut down, and suddenly there's no pumping of airborne gases into the atmosphere. That carries a cost. Did we learn anything from the experiment that we were drawn into for 4 years? Were we helped? I think some.
So you're talking about the kind of
the
climate change impact of COVID?
There were significant climate changes with lockdowns, and people were told, you're off the road. And they had pictures of nobody driving in some of the largest cities on the continent.
And deer coming back into cities, and right, like the bodies of water. I mean, I remember reading about this and doing some research about it myself for a piece, but in Venice, right, like dolphins and such were like water creatures were coming back in the city because there wasn't all this activity, right? So like a crisis forced us to shut down.
Yeah.
There were positive, visible, immediate effects, but you just wish that it wasn't a pandemic that spurred that sort of the drastic shutdown, I guess. And the positive effects.
Yeah, I mean, there's certainly you do see it in the data, even like looking at the carbon emissions are beginning to level off, and then with COVID, you can see in the data that a drop off. I mean, it was a blip really, because everything started back up again. But you can see a blip, and so you can see that
there are effects. Stopping
industrial processes does make a change. So in one, that's direct evidence that it can make a change, but maybe on the other hand, it also shows how difficult it is going to be. It's just a little blip. We have to stop things. Totally. And so obviously we can't just stop, put a halt to the world. Like, we have to keep living, but we have to learn new ways to using renewables and things like this. So it shows that what it would take to reduce emissions. It shows what it would take to reduce emissions.
Just back to the question of science communication, I think that is a big area that we would all benefit if it could be improved. And Ray has a PhD in in science communication, and maybe there's a whole genre of academia there, or a journalism that needs to be beefed up, because ordinary people don't understand that much about science. And
in fact, her thesis was on communication that obfuscates for the average person and removes them out of the conversation, and how can people be more effective communicators of scientific knowledge because of the genre of academic writing in the scientific arena, which tends to be specialist orientated, and which kind of blinkers the broadcasting dynamic. So that was her
interesting.
And part of the reason, I think, the learning of that is probably what it took for her to have simply a book amongst many to something that actually has garnered a fair amount of attention. I don't know what it is internationally, but in Canada, you don't get awards for nothing. Usually it's about how many people are buying the books and saying, I'm being helped by this. So,
maybe time for one more. Yeah, question or comment?
Just a comment, I would say. It's so reassuring to see the scientists talking about this topic and not melting down. It feels like you have the real facts. You know what's going on with the climate and holding hope for all of us. I think we need a lot more of that as just regular folks. So I appreciate that very much.
All right. Oh, go ahead. You can maybe ask over the break. We'll take 5 minutes and we'll come back for Larry and Patty.